All right, let's talk about that one thing that makes food go from just okay to absolutely incredible. The crispy skin on roasted chicken, the perfect crust on a loaf of bread, or that amazing sear on a steak. Well, that's not just cooking, it's science. And today, we're diving deep into the one chemical reaction that's the secret to making things delicious. So, have you ever really stopped to think about it? What is actually happening in the pan when you hear that sizzle? What creates that incredible deep golden brown color and that rich roasted flavor that just makes your mouth water? Well, spoiler alert, it's not magic. It's pure chemistry, and you're about to learn how to master it. So, let's meet the hero of our story, the Maillard reaction. This is the powerhouse process that takes food from bland to brilliant. It's the science behind that beautiful browning and, more importantly, all that flavor. So what's going on here, really? Okay, don't let the big words scare you. At its heart, it's pretty simple. The Maillard reaction happens when the basic building blocks of protein, which are called amino acids, get together with certain types of sugars. When you add heat, they start a chain reaction, creating hundreds of brand new complex compounds. And those compounds are what we see as browning and what we taste as delicious, savory flavor. You can boil it all down to this super simple formula. You've got your amino acids, think meat, fish, even bread. You've got your sugars, you add heat, and boom, you get an explosion of flavor. This is the fundamental recipe for deliciousness, and it's happening every single time you sear, toast, or roast something. Now, here's a key detail. This isn't just about cranking the heat up to max. The Maillard reaction has a very specific happy place. It really kicks off around 140 Celsius, or 280 degrees Fahrenheit. If it's too cool, nothing really happens. This is exactly why boiling food, which tops out at 100 Celsius, can't give you those deep, roasted flavors. You've got to get into that sweet spot. And hey, this isn't some new kitchen trend. A French chemist, Louis-Camille Maillard, first figured this out way back in 1912. That's right, over a century ago. But it wasn't until the 1950s that another chemist, John E. Hodge, really mapped out all the complicated steps that make the magic happen. All right, enough theory. Let's see this in action. We're going to walk through the life of a steak hitting a hot pan. Think of it as a play in 4 acts, the journey from raw to perfectly roasted. This is where the science gets really, really tasty. So Act 1, the flash off. The second that steak hits the hot pan, any water on the surface vaporizes instantly. See, moisture is the enemy of browning, so we need it gone. That clears the stage for Act 2, Maillard magic. The temperature rises, and we start to see that beautiful browning, creating all those nutty, meaty, savory flavors. Then comes Act 3, the fat factor. As the pan gets even hotter, the cooking oil itself starts to break down, adding those incredible, rich steakhouse aromas. And finally, we're at the finale, Act 4, the edge of char. Here, another process called pyrolysis kicks in. The food literally starts to char. A little bit adds an amazing smoky complexity, but you're walking a very fine line right before it turns bitter. It's a delicate dance. So when you bite into that perfect crust, what are you actually tasting? Well, it's not just one thing. It's a whole symphony of different flavor molecules all working together. Let's break down the orchestra.
This is so cool. We're basically translating chemistry into deliciousness. You know that unmistakable grilled smell? You can thank compounds called pyrazines for that. That rich, almost creamy, buttery flavor. That's ketones doing their thing. And that savory, almost oniony depth. That comes from thiazoles. Each one of these adds another layer to the final flavor masterpiece. Now let's clear up one major point of confusion. The Maillard reaction is not the same thing as caramelization. A lot of people mix them up. Caramelization is just what happens when you heat up sugar by itself. You get those sweet, sometimes a little bitter, caramel flavors. The Maillard reaction, on the other hand, needs protein. That's the secret ingredient that creates all those deep, savory, complex, meaty notes. Okay, so you've got the science. Now for the really fun part. How do you actually use this stuff? This is your blueprint for taking control of the Maillard reaction and making literally everything you cook that much better. And the best part is, you are in the driver's seat. Just follow this simple checklist. Number 1, and this is crucial, pat your food completely dry. Remember, water is the enemy. 2, use an oil that can handle the heat. 3, get that pan seriously hot before the food goes in. And here's a pro tip. Salting your meat ahead of time doesn't just add flavor, it helps pull proteins to the surface, which actually turbocharges the whole reaction.
And if you think this is just some fancy technique for professional chefs, think again. I love this quote from Nobel Prize winner Jean-Marie Len, who said, "The Maillard is, by far, the most widely practiced chemical reaction in the world. It's happening every single day in every kitchen all across the globe." So, from now on, you're not just cooking. You're a flavor chemist conducting a delicious experiment every time you step up to the stove. You've got the blueprint for browning, you've got the formula for flavor, so the only question left is, what are you going to make delicious next?